Hello and welcome to another video. Today I'm going to be speaking about Taylor series. So the standard notation for Taylor series is this, where this represents the first derivative, second derivative, or the nth derivative of our function at point A. A is a point, basically can be located anywhere. For Maclaurin series, A equals 0. So basically you would have x minus 0 to the nth power, which is always going to be just x to the nth power, and you would just simplify the whole expression as so. So you have a much simpler expression. You only have to evaluate the function and obviously all of its derivatives at the point 0, and you just have the various powers of x. Now, what does Taylor series mean? What's the intuition behind it? So if you have, let's say, a function such as e to the x, which looks something like this. Essentially what Taylor series does, it's a polynomial, so it's sort of like various expressions that carry on. Basically you're approximating the function. The more polynomials you do, the closer you are to the function, and therefore the more precise your Taylor series is. This is used extensively in physics, and I'm going to show you some example ideas. So, as I mentioned, the function e to the x, what you do first is you derive your function. We know that the derivative of e to the x is always going to be e to the x. Doesn't matter what's the whether it's the second derivative, third derivative, it's always going to be e to the x. And the point at which we're going to be evaluating it is going to be 0. So you could call this a Maclaurin series. Just really a special case of Taylor series. So we've got our derivatives. We see the pattern. It's always going to be e to the x. And then we just plug in the value of x at point 0, which is always going to be 1. E to the power of 0 is always 1. And we can carry on with our Taylor series now. So we're going to start. We're going to input the function value at point 0, so 1 times x to the power of 0 is always going to be 1 divided by 0 factorial, which is 1. This whole expression is going to be 1 plus our function is always going to be 1 at the point 0, so we don't really have to focus on this that much, but we have to focus on the polynomial. So x minus 0 to the first power, which is going to be just x over 1 factorial. This whole expression can be simplified to x, and then we just carry on. So x to the second power divided by 2 factorial plus x to the third power divided by 6, which is basically 3 factorial, and this carries on. I'm going to stop here. So at my first, second, third, my fourth point. Now all you do is you just input the value of x at point 0 at your given point. Could denote this as a. It's going to be 1 plus 1 times 0 always going to be 0, 0 to the second power, 0 again. So we're just going to have a series of zeros, and we can precisely say in this case that our function is going to be equal to 1. That's our Taylor series. That's how you would write it. Obviously, for a more general case, you just rewrite it like this. This is supposed to be point A, just so that I make things clear. So that's sort of a more general case. You would have e to the x times x minus a. This is not going to change, right? To the nth power divided by n factorial. A being the given point. Essentially what you might know if you previously studied functions is that all A does is just moves your function to the left. So when you have a minus sign, it just goes to the left hand side, and if you have a plus, it goes to the right hand side. So for example, let's say we have the function x squared. If our A is, let's say, 2, we have x squared minus 2, we would just move it by 2 points. That's all. We just move literally the whole function by these, by the number a. Okay, so now let's do a more complicated example. Let's do sine of x. We'll evaluate the function at point 0. And then later on we'll evaluate it for a equals 1. But let's do the Maclaurin series first. So again, you're just going to derive your function. Derivative of sine is always cosine. Then you do the second derivative, and really what you're doing, you're looking for some sort of pattern. Derivative of minus sine is minus cosine of x. Let's do the fourth derivative, which is going to be sine of x. Now, you can see that we are kind of repeating ourselves. So now you can probably see the pattern emerging. If we count this as n equals 0, so we would have minus 1 to the 0th power. It wouldn't really make sense, but obviously what we could do is when we input our value of our function, we input it at 0, what do we get? So sine of 0 is going to be 0, this is going to be 1, 0, minus 1, then again 0. So our values are going to be as follows: 0, 1, 0, minus 1, 0. So you know that for every odd value we have a 0, for every even value we have the absolute value of 1. So we either have a 1 or a minus 1. We're always going to have a minus 1. If we just count all the even terms as n, so this is n equals 0, and we have minus 1 to the nth power. The first one would be 1, second one would be minus 1, then again we would have minus 1 to the second power, so it would be 1, we would have 0, and then the minus 1. Based on this formula, really, you could sort of guess your value at the point 0. Be careful, this only applies for point 0. This is kind of the pattern that you're looking for. Just focus on the odd numbers, the even numbers, and just look for some sort of pattern. And now we are going to do the Taylor series of sine of x. So we're going to start with the derivative, or actually not the derivative, our function, sine of x times x minus 0, so we're just going to write x to the 0th power. I'm not inputting my a value yet, I'm not inputting it, I'll input it later. Over 0 factorial, then we get the derivative, which is basically cosine of x times x divided by 1 factorial plus minus sine of x times x squared divided by 2 factorial minus cosine of x times x to the third power over 6. And now we're going to input this for the a value, which is 0, kind of a Maclaurin series. First one is going to be, you can see it already, 0. Second one is going to be 0. Next one is going to be 0 as well. You could safely say that all the others are going to be 0. Now, you wouldn't have to do a Taylor series. All you would have to do really is just think about a sine function. Sine function at point 0 is always going to be 0. We don't have any sort of y value. With sine, we sort of focus on our y values. You can check that out in my other videos on trigonometry. So you could just really use your basic knowledge of the sine function. You wouldn't even have to do a Taylor series. What about at point 1? Again, you could sort of go through this hassle of inputting the value. So what's sine of at point 1? What's cosine at the point 1? Or you could say even at point pi. Just input the various values. You wouldn't really have to go and do a Taylor series. You would just input sine of pi half, and you could do it in a much easier fashion. Anyway, that's all for today. I hope you enjoyed the video, and next I'll be speaking and giving you more examples on Taylor series. So please like, share and subscribe. See you guys later.